just minimise that.
Okay, so today we are making a little video to help you with 3D printing. So we have a Prusa Mark III S, and it's a filament printer as opposed to resin. Because resin is a very smelly business and we don't want to get involved in that here at the moment. So basically what I've done is I've done a load of research, I've done a load of playing with the machine, and basically what I've done is I've put a little brochure together which is in staff shared D&T in a file called Prusa something or other. But anything to do with the Prusa will be in that folder. So you'll find the actual Prusa manual, because they don't send one with the machine, it's electronic, so you have to download it and convert it through PDFs and goodness knows whatever else. And I've made, like I say, my own little basic one. So if you've never used a 3D printer, this will help you get going in a very quick and concise manner in a step-by-step format, which helps you to not have to read tons and tons of stuff to get going, basically. So the idea is, what do you need to get going? Well, to print, you need three basic things. You need a file to print, and that will be an STL file. You need software that processes it, and that is called the slicer. And then you need a good 3D printer. So we've already got our 3D printer. And then on the computer, what you will see shortly as I go through the process is that the slicer software is already loaded onto the computer. But what we need first of all is a file that we can print. So where do we need to go to? So if we head over to the computer, we are screen recording this at present to make it easier for you. But basically, if you go to Google, I mean, I've got several tabs open here, but if you go to Google and open a new tab and search for Thingiverse, and you click on it and open it up, and this is the home page in Thingiverse. And what you have in here is loads of files, and they should all be STL files if they're going to work, of things that people have created free of charge. Now, even if some of them look a bit irrelevant or a bit sort of pants or a bit fanciful, whatever you think of them, actually creating that STL file from nothing is quite difficult. You need to know quite a bit of geeky stuff to be able to do that. So it's far easier to go and have a look. Now, you can scroll down, and as you can see, there's only a certain number of things on the page, but then there's a page scroller here. So you can go to page 2 and then scroll bar and have a look down and see if you can think of anything. Now, if we click on that one and just open it up so you can see that picture a bit bigger, there's a Darth Vader phone holder, which, you know, if you're a Star Wars fan, might be quite nice. But that's quite a fair print. Now, what's interesting, if you click on the parts of it, as you can see, there's lots of bits. The head is separate, and the reason that is probably separate is because there are certain bits of that, a lot of it wouldn't need supporting, but I reckon the two arms there would need some support, because the layer that is being printed is so thin, that first layer, as it works its way round and starts to print the first layer of that arm, it will just flop down. So you'd need supports between the bottom of that arm and the bed or the base. And then you have to cut those out afterwards and make good, basically. But so you do have to understand a little bit. But if we go down and have a look, it tells you a bit of stuff, bit of information about it. but most important, 9 comments. So it's always worth having a look at the comments section and seeing what comments people made. Like, interestingly, it's showing 2 comments, and then there's obviously 7 replies in total. So there's more replies than there are comments. I'm not going to read them now because it will take up too much time. But if we go to download all files, what happens is you'll get a box in the side like that, and when it's finished and the circle was finished scrolling, you click on that and open it, and then go to files and unpack it, open it up, and then you can start looking at the various component parts of that file. So let's close that, but that's how to do that. But the other interesting thing is if you just click on one image, will it do it? Oh no. Okay, let's go to there. Let's see. Oh, there we go. There it is. Right. So things files, or thing files. If you download just one of those rather than download all, watch what happens now. The file appears there, but when you click on it to open it, instead of needing to unpack it, it opens Prusa Slicer automatically. You'll get rid of that dialog box because we don't need it, and it puts it on your bed straight away. And then over here you can check infill 15%. That's the amount of squiggles and garbage that is put into the middle. I don't know if you can see that. Let's bring that right up to the camera. Can you see the squiggles and the garbage in the middle? If I turn it up that way a bit, you get a bit better light on it. Hopefully you can see that. So that's infill. Now, the more infill there is, the more time it will take to print. So you don't want to go mad, but you kind of need a little bit, depending on what you're making. There are some things you could probably make, like that dice doesn't really need an infill, to be quite honest with you. And when you get a bit more advanced, you can do an extra wall thickness and make that wall a little bit more robust, and then you don't need an infill at all. So it will print even faster. So when you get a bit sort of knowledgeable, I think is probably the best way to put it, you can get more proficient. I'm trying to find the words. So we've got quality. So if you open that, you can go down to 0.005, ultra detail. Now that's fine, but that could take a print that might take half an hour in average quality to 5 hours in really high quality. So again, you have to know a little bit before you start interfering with your settings. So if you now go slice at the bottom, it slices the G code, and what that does is it sets it up and makes it ready and prepares it. Now, if you now look at this right hand side of the screen in the bottom corner, it tells you the size, it tells you how much filament is used, it tells you the cost of that filament, and it gives you an estimated printing time of 38 minutes to print that hat. Now, we're going to close that because we're not actually going to print it, so we don't need it. But I wanted you to see that if you print a single file, it can go straight to slice, or if you download all, you have to save it somewhere and unpack it, and then know where you've unpacked it and saved it to. If we go back to our main, so that's back to the home page. So just one more thing quickly. You can use the search bar to search for something, but just to give you a quick idea so that the video doesn't take too long, if I type in spanner and then hit return, which will do the search, as you will see, you get some spanners and you get a lot of spanner related stuff. Yeah, and that's probably, ironically, one of the best spanner searches I've ever had, because sometimes random stuff comes up and you think, what on earth is that to do with a spanner? But actually that one's returned quite a good search, because it's all spanners of various types or spanner racks. But the first time I did it, I got all sorts of random stuff in between the spanner related stuff. So the search engine isn't fantastic, so you do have to be a bit patient. But it will speed the process up, because to give you an idea, over something like 3 or 4 days, I just looked continuously, page after page, through about 600 pages, and didn't find that much that interesting to make demonstration pieces out of. So you do have to be a bit patient. Right, so that's Thingiverse. That's basically what you have to do with it. So now let's talk about the materials. So the material that you're going to use mainly is PLA. That is your general purpose material for 3D printing. Now there are other ones. There's PETG, and there's ABS, and there's probably a whole list of other ones as well. But those three are the most popular, and they have different benefits. So PLA is very popular because it's got no smell. It's a little bit on the brittle side. It's not very thermally resistant. PETG has the benefits of PLA, but it's a lot less brittle, and it's more thermally resistant. And ABS is going to be replaced by ASA. That also has the benefit of PLA, but is UV resistant, less warping tendency, and also low odour. So again, sort of horses for courses, I think is fair to say. You choose the type of filament that is relevant to the printing that you're going to do, and you know, once you've got some basics going and you start getting knowledgeable, you can get much more advanced filaments for doing all sorts of. I think you can even get like a silicon filament to make silicon molds and things like that. So it does get involved once you really know what you're doing. So getting started, obviously we've looked at the computer, we've looked at Thingiverse, you've downloaded your STL file, you've unpacked it and saved it to a place where you know where to find it. You have a look at the file, you read any comments about it, you read the person's printout or profile of what they've created, and you see what they recommend. So often the person who's created it will recommend what kind of infill it needs, what quality it needs, etc., etc. So it's worth doing all that. So that's the computer side. What we're going to do next is we're going to move over to the 3D printer itself. So I'll show you the 3D printer and how that works. But before I leave quickly, hopefully you can see that. So that's my hand. Into the PC is a card reader. What we have is an SD card which we put in there. When you go to slice in the bottom, and then the screen comes up and you see that multicoloured image of the product, at the same button at the bottom says export G code. If your SD card is in there, when you export the G code, it will save it to that reader. If it doesn't, then you need to go through your file process and make sure it's, instead of saving it to your PC, it's saving it to the USB, which will be that, basically, that's the equivalent of the USB. So once it's saved on there, you can pull your SD card out and then pop it in the machine. But what I'll do is I'll show you that when we get to the machine, and we can stop that there because we are now ready to move over to the machine, and we will need a little reset. Ladies and gentlemen, here we are at the machine. So this is our Prusa Mark III S, I believe, by Joseph Prusa. This is a very popular model, really good. So what I'm going to do quickly before we actually get into the print, I'm going to tell you a little bit about your PLA again. So this one, the silver one, which I think the camera can probably just about pick up, but I'll pull my hand down here. So this silver one, this is a really good quality one. This is the one that came with the machine. This one was a separate one, and it's not as good quality. We've had a lot more problems with printing, a lot more difficulty with printing than this one, and that could be for several reasons. So I'm just going to quickly highlight those before we move on. When you buy a PLA, you can buy cheap PLA, maybe £7 a roll, as opposed to this, which I think is more like 20 or 30 quid a roll. But these will come sealed in a bag. So they don't absorb any moisture or dampness, or no impurities. But if you buy a cheap one, it could be loaded with impurities, and the more impurities and water and moisture and stuff that it's absorbed from the atmosphere, or if it's packed somewhere and it's transported and there's maybe oil in another box that's dripped out and oil's dripped onto it, it's going to totally wreck your 3D printing. So the quality of your PLA is really important, paramount, I would go so far as to say, because any weaknesses in that, you're probably going to waste like a whole roll of PLA trying to get things to print that won't print. So I'm just going to quickly show you. So I'm going to have another go at this dice, but if I get those right up to the camera. So I'm going to try and print this dice yet again. So if you look at the thickness, the first time it printed, it failed at just under halfway, and that one it failed at just over halfway. And I think the reason for that was I didn't bother putting glue on the base, because the surface area I thought would be enough relative to its overall size to hold it down. But no, it got to a point where a little error, you know, a little bit of plastic maybe bunched on the corner, and it just knocked it off the bed. So I'm gluing it this time, and I'm hoping and praying that that's going to be enough to hold it onto the bed to complete the print. We'll see what happens. So the next thing to say before we start the print is I have used acetone, or you can use isobutryl alcohol, but that bed needs to be spotlessly clean each time you print. Any impurities on the bed is going to mean that the item can be knocked off of it or removed from it easily, or if you were printing something that was a bit on the thin side, the layers might start to peel off. There's all sorts of things that can happen. So to ensure your best possible print, that bed needs to be thoroughly clean. And in this instance, because this is the centre of the bed, so this should be where it's printing, I've applied a little bit of glue. That's not Pritt stick, that is like a Pritt stick, but it's designed specially for doing this. So that's a bit about the PLA, a bit about the cleaning of the bed. So what we've done, you saw in the last part of the video that we took the SD card out. The SD card can only go into this slot one way, and if from memory, it should be contactors facing you. Yeah. So with that in, what we do is I'm going to press that, and what you'll see on the screen, actually if I move my finger out of the way, you get info screen, preheat, print from SD, load filament. Well, the filament's already loaded, so what we're going to do is we're going to use the toggle, and the little arrow at the side is next to print screen, and now we press the button, and what we're going to do is we're going to toggle again, and the arrow is coming down. We don't want the skull. There there it is, dice, solid, round, press the button, checking the file, now it's heating the bed and it's preparing to do its print. So basically, it seems complicated initially, but it's not that complicated. So once you've done a selection by pressing the button, scrolling through, if you like. So if you were on a computer, you'd open an email or whatever, and then you'd scroll down to read the whole email. And this is kind of similar. So you press the button and it activates whatever, or you scroll down so that the arrow comes down to whatever heading you want, and there's more that can be seen on the screen. So you might only have 4 titles on the screen, but that scroll button can carry on going and more will come up. So there's quite a lot on that SD card as an example of things that I've saved which I might want to print again. So there's no point in deleting them, because in deleting them all you do is damage the card long term. It's easier to put things on there that you might need again, and just have more SD cards. I'm not going to get into the science of recording and deletion and all the rest of it, but the more you record and delete, the more the whether it's a CD drive in a computer or an SD card, it degrades it. Anyway, so there we go. The bed's heating up. Now, what's going to happen, I'm just going to give that nozzle a little wipe and make sure there's no junk on there. So, as I said, we've cleaned the bed, we've glued it so that it's ready to heat it up, to hope that it holds the next dice on in place. When that's hot enough, when the bed's nice and hot and everything's ready, this will go through a check sequence. So it will, right, there we go. You probably won't be able to see that, but there's filament that's squidged out. So that's telling me that the nozzle's now getting up to temperature, and the bed is probably going to be there fairly soon, judging by the fact that it's just ejected an inch of liquid PLA. While we're waiting for it to finish its heating process, one of the things I will mention, here it is, it's just going to start going through its checks now. But one of the things I'll mention while it's doing that is when you finish the print, unless you're going to do another print almost immediately, yeah, you want to clean the bed and turn the machine off. Because what I've learned is that if you leave it on, if you imagine the nozzle was a funnel, imagine a funnel that you were going to pour liquid into a bottle with. Yeah, the nozzle is a bit like a funnel, so it's this wide at the top, comes down to a tiny, tiny little point that's like probably less than 1 millimetre in diameter. If you leave the machine on, that head, this hot head under there, is staying hot a lot. And eventually what it does is it cooks the plastic, and the plastic starts to bake to the inside of the nozzle and basically makes that smaller and smaller and smaller till eventually it's just not going to print properly. So there we go, there's a little smudge of muck. Now, so hopefully you can remember that. So what it's done is it's done a level test, and because it's happy that it's level, it comes over to this corner and it prints a strip to get the filament going. So don't think, oh, why is it printing there? I need to stop it. It always does a test stripe at the top edge here before it goes into the middle. And what I'm going to do, because I've got the muck that comes off before, when it prints something, it always prints a boundary. I don't know if you can see that. It's hard for me to see it because I'm looking at it against a light background, but if I bring that right up close. So it prints a circle around what it's printing on the bed. And again, that means it's printing some stuff out before it actually starts the print, to make sure that the nozzle is releasing the liquid PLA at an even consistency, and hopefully everything's working okay. Now, obviously, one of the difficulties that you'll probably realise fairly quickly is you can't really see what's going on until it's actually printed quite a bit. You get little snippets if you're looking at it from the right angle, from the right side, and I'm having to bend right down to look at that, and it does appear to be printing okay, but as you can see, I wouldn't want to walk away from it and leave this, because first one got a third of the way through, second one's got half of the way through, and everything looked like it was going fine, but for some unknown apparent reason, it had a fault. I'm not really sure why. Sometimes it literally, you might just get a globule that just hardens just fractionally too quickly, and that then knocks the item and pop off the bed it comes. So some people do leave these things printing overnight, but you can waste an awful lot of PLA that way. So it wouldn't be my recommendation, certainly. So now we basically just have to sit back and wait, and that dice, according to the information, if you remember in the early part of the video we were looking at the screen, in the bottom corner it tells you quality of print, amount of infill and all that kind of information, and at the very bottom it tells you the actual time it will take to print, and this was about 30 minutes approximately. So we're probably not going to watch 30 minutes of printing, because that'd be quite dull. We might record it all, and obviously if it prints okay there'll be an edit and you'll see the dice in all its glory at the end, hopefully, if nothing goes wrong. But if it does go wrong, we'll capture it on video, hopefully, if the camera doesn't let us down. And you can see the frustration that 3D printing can cause, because it doesn't matter how hard you try or what you try and do, you know, it can just fail for whatever reason, and there doesn't appear to be any rhyme or reason to it failing, unfortunately. So you just have to let it go and do its thing, and as you can see already, it is, I mean, my eyes are terrible, but that seems to be lifting off the deck and doing its thing. Whichever way you look at it, I mean, it is quite amazing that it can liquid ice plastic and squirt out an even filament. I mean, if you think about icing a cake, if you ever tried icing a cake, how difficult that is. You know, a machine is liquidizing plastic and squirting out an even layer that is microns thick, and it has to squirt it out, and then it has to dry before it comes around again. And if you think about that just for a few seconds as a process, it's hardly surprising it's not always plain sailing. But there you go. So I'm going to shut up waffling, because I think I've told you at this stage all you need to know. And we will let the cameras do their stuff and record it, and if it all goes according to plan, you will see a nice dice in the end edit, or you will see the machine throw a wobbly at some point. Let's hope it's the former, not the latter. Are we going to get away with it? I think you know why we're getting away with it? Because it's gone into the radius bit. So the lump's at the side of the square bit, and as it's coming in, the nozzle's just missing it. But see, that's what it does. If you come around here you can see it on this corner. There's a big globule on that corner.
Yeah, I see it.
And that's what's happened. That's hardened up, and that's what's happened to them two. And the nozzle's hit it, and it's fucking knocked the whole dice off. But I think we're just about going to get away with it this time, because it's so close to the finish. There you go. We've just got away with it. Now, you're going to like this camera. You're going to like this. This, I'm going to pick it up in a minute, if I can get it off that bed. Now, oh, look at that. That wasn't too hard to come off. Right, I'm going to bring that right up. Look at that. That little globule. Oh, bugger. That little globule was stuck on there. And there's another bit. And when they harden up, those little globules are what cause it to get knocked off the bed. So this will now need cleaning with acetone. I'll turn that off because we're not going to do another print today, but I'll clean that tomorrow. But those little globules, I don't know why they form or how they form, but we've managed to get away with a complete dice this time. But they form for whatever reason. Obviously, as the PLA is going round, let's say it starts in this corner. By the time it gets to that corner, this is starting to solidify. By the time it gets back here, this should be hard enough so that it can then lay down the next layer. And somewhere in that sort of process, if it hardens a bit too quick and you get a lump, or I don't know, maybe there's too much coming out of the head, I really don't know all the answers. But fortunately, the globule formed. Again, if I just... One of the things that's really hard is I don't know how much... If I bring that right up close to the camera, can you see the corners are radiused? And I think we were lucky that the globule formed